So today we're going to start section 1.1, which is 4 ways of representing a function. Should be a review from Algebra 2 and Pre-Calc, but just how we graph and how we represent various functions. Alright, so the first way that we represent a function is verbally, which is just a description of words. The second way we might represent a function would be numerically, which would be like a table of values. We can represent a function visually by making a graph, or we can represent a function algebraically by writing an equation. Okay, and so let's look at what a function is. Let's review domain and range, and review the vertical line test. Okay, so a function is a rule that assigns exactly one domain value, or one x, to exactly one range value, or exactly to one y. When we're looking at the domain of a function, we're looking at just the set of all the x values that make up that function. For the range, we're looking at the set of all the y values that make up that function. And our vertical line test, often abbreviated the VLT, is a test that tells whether or not a graph is a function. Okay, so the first thing I'm going to do is I'm going to plug x plus h into my function everywhere that I see x. So I have 2 times x plus h squared minus 5 times x plus h plus 1. Okay, and then it tells me to subtract f of x, so I'm just going to subtract my whole function. So minus 2x squared minus 5x plus 1. I'm going to put that in parentheses so I make sure I subtract each piece. And then that whole thing is divided by h. Okay, so if I start with x plus h squared, x plus h squared, if you FOIL it, becomes x squared plus 2xh plus h squared. Okay, if I distribute my minus 5, I get minus 5x minus 5h. Then I still have my plus 1. And if I distribute my minus sign, I get minus 2x squared plus 5x minus 1, all divided by h. Okay, if I distribute my 2, I get 2x squared plus 4xh plus 2h squared. And then everything else stays the same. So minus 5x minus 5h plus 1 minus 2x squared plus 5x minus 1, all divided by h. Okay, so let's start crossing off things that cancel. Just try to make it simple. So I have a 2x squared minus 2x squared, so I know that's going to cancel. I have a minus 5x and a plus 5x that cancels, and a plus 1 and a minus 1 that cancels. So I'm left with 4xh plus 2h squared minus 5h, all divided by h. So then I know that I can factor out an h out of the top because everything has an h in it. So 4x plus 2h minus 5, all divided by h. So my h's cancel, and 4x plus 2h minus 5 is my answer. Alright, that kind of ring a bell. I kind of remember doing that, or do you want to do another one? Does that make sense? Okay. Alright, so the last type of function that we're going to look at, functions that we're going to look at today, are piecewise functions. And piecewise functions are pretty much exactly what they sound like. They're just pieces of different functions, so different formulas that form a graph. Alright. So if I look at example 7, I'm given the function 1 minus x when x is less than or equal to 1, or x squared when x is greater than negative 1, or x is less than or equal to negative 1, or x is greater than negative 1. And it wants me to find various function values. So if I start with f of negative 2, if x is negative 2, then which function rule do I use, the top one or the bottom one? Meaning, is negative 2 less than or equal to negative 1, or is it greater than negative 1? less than, right? Negative 2 is less than. So I know that I'm going to use this top value, so I'm going to use 1 minus x. And since x is negative 2, that gives me 1 minus negative 2. And what is 1 minus negative 2? 3. So I know at negative 2, I'm going to go up to positive 3. Then if I look at negative 1, if I want to find my function value at negative 1, is negative 1 less than or equal to negative 1, or is negative 1 greater than negative 1?
It's equal.
It's equal to, right? So we're going to use the top function again. So 1 minus x. And since x is negative 1, 1 minus negative 1, which is 2. Okay, so at negative 1, I go up to positive 2. And then lastly, if I look at f of 0, is 0 less than or equal to negative 1, or is 0 greater than negative 1? Greater, right? So we're going to use the second function. So we're going to use my x squared function. And if I plug in 0, then for x, 0 squared is 0. 0 squared is 0. So then at 0, I'm at 0. Did I graph that I had? Yep, thanks. Thanks, Jenna. I was really confused for a second. All right, negative 2, 3 is back. Negative 1, 2 is back. And then we have 0. So then if I connect my points, I can see how my piecewise function is defined. Does that make sense?
Yeah.
Okay, so you guys are going to start on page 19, number 4, 6 through 11, 13 through 14, 27 through 30, and then 47 through 50.